Welcome back to our last lesson in Unit 12, guys. We're going to be talking about electrolytic cells. Don't forget, these are the topics and the chapters that you guys need to be focusing on. And today we're going to be covering electrolytic cells, their parts, comparing them to voltaic cells, and finally, what are some of the common uses that we see in industry of electrolytic cells.
So, what is an electrolytic cell? It is a reaction that is not spontaneous because we're forcing the reaction to actually happen by applying an outside electrical source like a battery, which is voltaic, in order to create the reaction. The process in which electrical energy is used to bring about such a chemical change is called electrolysis.
Electrolysis is the concept of reversing the direction of a spontaneous reaction in a voltaic cell through the input of electricity, and that is how electrolysis works.
Right, so think of recharging a cell phone battery.
Yep. By plugging your cell phone into the wall, then you get electrical current that comes in, making the entire voltaic reaction go in reverse.
Right. So in a voltaic cell, electrons flow from negative to positive. And that's spontaneous because electrons are negative and they go towards something that is positive. In an electrolytic cell, that is reversed, however, which is why it's non-spontaneous, because electrons don't like negative charges.
So electrons flow from the negative end of the battery, and they flow.
See?
Flow. Electrons from the negative end of the battery flow through the wire to the electrode, which is now negative and becomes the cathode. Ooh, I think there's a reason why they're bold and colored. The electrode attached to the positive end of the battery loses electrons to it, and it is now positive and becomes the anode. So the electrodes that are attached to the positive end of the battery are positive, and the electrode attached to the negative side is negative. I can't forget that. That's pretty easy.
So similarities, both use redox reactions. The anode is the site of oxidation in both cases. The cathode is always the reduction site. The electrons flow from anode to cathode, and anions flow towards anodes and cations flow towards cathodes. And then finally, the anode loses mass while the cathode will always gain mass.
Some of the differences is that in the redox reaction in the voltaic cell is going to be spontaneous. It is non-spontaneous in an electrolytic cell. In a voltaic cell, the anode is negative and the cathode is positive. In an electrolytic cell, the anode is positive and the cathode is negative.
Okay, so those are the only differences between the two cells, which is the only reason why one is spontaneous versus the other is
Spontaneous.
Yeah, I hopefully, I feel like they would have put that word in, but maybe not. I don't know, maybe.
So looking at these two diagrams, you're noticing on the left we have our voltaic cell with its electrolytes in a solution. You'll also notice that there is a porous salt bridge or a plate of some sorts, and you're still seeing the flow of electricity. So the voltaic cell is the battery. So when you look at B, which is the electrolytic cell, everything that we're seeing to the left in picture A, that is all found inside of the battery, which is found in the very top of the electrolytic cell. So that supplies our electricity, which then goes down into our electrolytic cell, which the electrolytes are, and there will be a flow of the electrons from the negative to the positive terminal.
Also notice that the battery is there to kind of coax the electrons away from the anode and push them towards the cathode. So notice that the anode is connected to the positive, allowing the electrons to try to, attract to them and then be pushed the rest of the way. An electrolytic cell is used for electroplating, so one of the main focuses on the reagents is this electroplating use of electrolysis, and it's just trying to get a metal to cover an object that you want. So like those little baby booties that get bronzed.
That's electroplating. Or most times some fancy looking silverware, for example, if you use it too much, you'll start to notice that they actually have a copper base metal underneath it. So that's an example of electroplating because you're actually putting silver atoms like paint over top of a cheaper quality base metal.
Yeah, there's probably girls that have gone to the mall and bought like silver plated jewelry. That just means that they were put into an electroplating system and the silver was attached to the outside of probably stainless steel.
Yeah, it's just like painting, just with metal atoms.
Yeah.
So again, this is what an electrolytic cell looks like. You're noticing the center between the anode and cathode, that big bar, little bar, that's always represented of a battery. So that's like your symbol when you get into physics of what a battery looks like. But again, as we see, your plating material, which is part of your anode, that stuff that the actual metal is, that plating material, is actually being transferred through the solution onto the surface of the metal that you want to plate, which is going to be on your cathode.
Finally, it starts at the anode. Electrons are lost there. They go through the wire and into the battery this time.
Yep.
They enter the cathode and they still reduce cations. And then the anions always flow back towards the anode.
Ta-da!
Name that song.
I don't know what that song is, but hope you guys like this lesson.
Adios.